Today, we're going to dive into one of the most mind-blowing facts about the human brain. It's not really one single mind, but two super specialized halves, and a lot of the time, they're working without the other one even knowing. And you know what the key to understanding this great divide is? It all comes down to language.
So let's just start with a kind of wild question. What if you literally had two different minds, two separate consciousnesses, sharing the same skull? I know it sounds like something straight out of science fiction, but for some people, it's their actual reality.
So how is that even possible? Well, to figure it out, we've got to become detectives and investigate a really fascinating and frankly pretty bizarre medical case, the mystery of the split brain patient.
Okay, so picture this. It's the 1960s, and doctors are trying to treat patients with terrible, life-threatening epilepsy. They come up with a radical surgery where they cut the corpus callosum. That's this thick bundle of nerves, kind of like a superhighway of information that connects the brain's two hemispheres. Now, it worked. It stopped the seizures. But it also did something else. It created this incredible, unprecedented way to study each half of the brain all by itself.
This is where it gets really interesting. Researchers like Sperry and Gazzaniga designed these clever experiments. They'd flash an image to the patient's left visual field, just for a split second. Now, because of the way our brains are wired up, that information goes only to the right hemisphere of the brain. The left brain is completely in the dark.
So in this case, let's say the image they flash is a hammer. Okay, so now the picture of that hammer is locked away inside the patient's right brain, and only the right brain.
The researcher then asks a really simple question. What did you see? And the patient, without even hesitating, just says nothing. As in, I saw absolutely nothing. It's like the hammer was never even there. But this is where the mystery really starts to get good.
So next the researcher says, okay, I want you to use your left hand. Reach behind this little screen and pick up the object that you saw from a few things I've hidden back there.
And get this, the patient's left hand goes in, feels around, and without any trouble at all, picks up the hammer, the exact same object the patient just said, out loud, that he did not see.
So what is going on here? This is a huge puzzle. How can a person's mouth say one thing while their hand does the complete opposite? It's a total contradiction. To solve this, we need to pop the hood and take a look at how the brain is actually organized.
And this brings us to the two very different personalities living inside your head, the distinct characters of your left and right brain hemispheres. You know, you can almost think of it like a partnership. Your left brain, that's usually the analyst. It's the one that handles things like logic, math, and, this is a big one, language. Your right brain, on the other hand, is more of the artist. It's amazing at recognizing faces, feeling the rhythm of music, and understanding where things are in space. They just have different jobs.
Now, here is a super important piece of the puzzle. Your brain's wiring is all crossed up. It's a principle called contralateral control. It just means the left half of your brain controls the right side of your body, your right arm, your right leg, and the right half of your brain controls the left side. This little fact is our first major clue.
Okay, with that in mind, our next clue is all about finding the brain's main command center for language.
So check this out. For the vast majority of people, we're talking a whopping 98% of us, language isn't spread out all over the brain. Nope, it's heavily lateralized, which means it pretty much lives in one specific place, the left hemisphere.
And we can zoom in even closer inside that left hemisphere. Take a look at this map here. See those two critical zones? You've got Broca's area up toward the front, which is like the director of a movie. It plans out how you're going to make the sounds of speech. And then you have Wernicke's area, further back, which is like the interpreter. Its job is to understand what language means.
So think about it. Every time you want to say a word, it's basically a three-step dance. First, your brain picks the word. Second, that info gets zapped over to Broca's area, which figures out all the muscle movements you need. And finally, Broca sends those instructions to your motor cortex, which then moves your mouth and tongue to actually speak. It is an all-star left hemisphere operation. Okay, now we have all the pieces of the puzzle. We know about the brain's two different personalities, we know about the crossed wires, and we know exactly where language lives. It is time to finally solve the mystery of the split-brained patient.
Okay, let's put it all together. The image of the hammer, right? It was sent to the right hemisphere, the silent, artistic side of the brain. Now, since the right brain controls the left hand, it had no problem guiding that hand to pick up the hammer. It knew what it saw. But, and here's the kicker, the speaking part of the brain, the left hemisphere, saw nothing.
And because that superhighway, the corpus callosum, was cut, the right brain had no way to send a message over to the left brain to say, hey, psst, I saw a hammer. So when the researcher asked, what did you see? The speaking left brain gave the only honest answer it had, nothing. You've got two minds in one body with a broken telephone line right down the middle. And listen, this isn't just some weird theory from a lab experiment. We see more and often tragic proof of this in patients who suffer from something called aphasia. It's a language disorder that's caused by brain damage, usually from a stroke. Aphasia really gives us a stark, clear window into what happens when those language headquarters in the brain get hit.
For example, if Broca's area is damaged, you get this very halting, broken speech. The patients know exactly what they want to say, but they just can't get the words out smoothly. When one patient was asked about his old job, all he could manage was, carpenter, 20 years. The understanding is there, but the production is just broken.
Now compare that to what happens when Wernicke's area is damaged. A patient with Wernicke's aphasia can speak totally fluently, with normal rhythm and everything. The problem is, the words are just a jumbled mess of nonsense. They can talk, but the meaning is gone. The speech-making machine is working, but it's putting out gibberish.
So after all that, what does this actually mean for how we think about ourselves? We've seen how the brain is split, how language is kind of locked away on one side. Let's pull back for a second and look at the really big picture.
So let's just do a quick recap. We've learned our brain is basically two halves, each with its own special set of skills. For almost all of us, language is tucked away in the left hemisphere. And we've seen that specific spots, like Broca's and Wernicke's areas, have very specific language jobs. And maybe most importantly, that connection between the two sides is what's absolutely vital for creating the seamless, unified feeling of just being you. And this brings us to the biggest question of all, one that really goes beyond the science and gets to the very core of who we think we are. You see, the split-brain patient, they don't feel divided. They feel like a single person, just like you or me. But these experiments show us two different streams of consciousness, two minds living in one head where one of them literally cannot speak for itself. It really forces you to ask, if the only thing holding our consciousness together is a physical bridge of nerves in our brain, well, how real is that feeling of being a single, unified self that we all just take for granted?